Hello everyone, how are you doing? Welcome to my YouTube channel, and here I am with another video, and today's video is on JavaScript. But before we get started, I would like to ask you a few questions. Have you ever learned to form a sentence without learning about word? Or have you ever formed any word without learning about alphabets? I think not really, right? So programming languages are also like any other spoken languages. It has some rules, it has some ways of learning it, and once you do it right, you learn it forever. Hey, this is Tapas. I'm going to teach you today how to learn JavaScript effectively, such that you will hardly have to kind of go back iteratively to books and tutorial again and again to remember any topics. I'm going to talk through a few tips. I'm going to talk through a few ways and few logical ways of handling this learning, right? So if you haven't subscribed to this channel, please go ahead and subscribe. I keep sharing a lot of good content over here. And if you have already done so, thank you very much. Without any further delay, let us get started and dive into the topic. All right, so the funny part of today's topic is, yes, we will not write any code. I know what you are thinking. You're possibly thinking, he's talking about learning JavaScript, such a big topic, and he's talking about, no, you're not going to write a single line of code. Yes, that's true. So our focus today is learning JavaScript. And the moment we talk about learning JavaScript, I'm sure there are plenty of topics that keep appearing in front of your eyes, right? You see these topics are bubbling out. The topics like interpreter, parsing, execution context, binding, hoisting, functions, call stack, base keyword, scope chain, pure function, closures, loop, conditions, promises, asynchronousness, data structures, events, modules, things like that, DOM, data types, debouncing, whatnot. Things that just keep coming, and they keep coming. And there is no end to it. I have ended here because I could not accommodate more bubbles over here. So once you see things like this, obviously you get upset. You get upset because there are so many things to tackle. And that's the whole purpose of this video. That's why I thought of creating it, so that I tell you what is the right way of learning JavaScript, at least targeting to learn JavaScript, so that you don't worry about so many things around you. You just don't get confused. Like, can I do this? Can I really learn this? Is it possible for me? How many courses are I need to go through? How many times I have to go through a particular course? It's too much to learn. It's too much to take. And how am I going to remember so many topics, so many things? What am I going to do, right? So in a nutshell, you just say like, how do I really learn JavaScript? That's the whole point, right? So now I want to introduce the JavaScript learning model, or the JavaScript learning mental model. That's what we're going to talk about. That's what we're going to learn from here. So what is JavaScript learning mental model? This is nothing but a few fundamental rules. We want to talk about a few fundamental rules and want to stick to it very, very strongly throughout. And one disclaimer, all these things that we're going to talk about are not easy to start with, but if you are keeping it in your mind and brain, your learning will be much effective. All right, so let's get started. What is the rule number one? The rule number one is you need to learn the programming concepts. Whether you are learning JavaScript, you're learning Java, Go, Python, whatever languages of the world, whatever programming languages of the world, there are certain programming concepts which are common. And those programming concepts you should learn isolating it from the programming language that you're focusing on. For example, if you're learning JavaScript party for some time, but first learn this programming concepts. And what are those? I will discuss some of this in this video. Next, always think about concepts before the syntaxes. What is syntax? Every language has its grammar. If you're talking in English, it has grammar. If you're talking Hindi, it has grammar. Similarly, a programming language has certain amount of syntax. Otherwise, it might affect adversely in your programming. So concept first, then the syntax. We'll discuss what does it mean. Create a mind map of JavaScript promises. If I just search about this keyword or just search about promises, or I'm actually taking a course and then following the things and landing into these topics, I may still not understand if I don't create a mind map of it. I may not still understand if I don't know that this keyword is influenced by so many things of JavaScript, and I really need to focus on those or keep in mind those topics because I am learning this. If I'm going to interview somebody asking, hey, something about promises, I really need to know some background story of some other topics so that I can actually solve any problem that comes for JavaScript promises. That's why the mind map is important. We're going to touch base that. Then practice incrementally. What I mean by that, for example, you learn about, say, JavaScript function, and then you're going to learn about scope and scope chain. Then you want to learn about closures. So take one example, start with a JavaScript function. Then with that particular example, extend it to learn about scope chain. Extend the same example to learn about closure. The real importance of this approach is when you are learning closure with that example, the extended example that you had started for functions, you are actually remembering where are you coming from. So your brain works in a way like, oh, I have used a part of it in the function, another part of it in the scope chain. Now I'm using it in the
the closure. So things get kind of connected. You will be able to connect the dots. So practice incrementally. That is important. People say JavaScript is very weird. I say also because in certain cases when you only see the syntaxes, JavaScript will sound weird. It will sound something which is like very, very unnatural because you're focusing on syntaxes, you're not focusing on concepts. We'll take a few examples where we'll say how JavaScript is weird and why concepts help. But for now, don't care. Don't care about the weird things. Most of the times you won't be using these weird things at all. Okay? Then build projects that connect the concepts. Important thing. We won't be diving very deep into this one in today's video, but in future videos, I'll be talking about the projects that you can build from several JavaScript concepts binding together. Okay? So these are the points. Programming concepts more than syntaxes, mind map, practice incrementally, don't care about the weird things for now, and build projects. So that's the mantra. All right, so let's go and start thinking about programming concept. What exactly programming concept is? Now, the first programming concept I want you to focus on is variables. What is variable? Variable is something that you can create in your programming so that its value you can reuse in different places. As simple as that. You create a placeholder, assign some value to it, and that particular thing you use elsewhere so that you don't have to do some kind of repetitive code. That's what is variable. For an example, a variable can be a car, student, or just any name that you want to give. Values is basically the state or the particular quantity or the thing that you are assigning to a variable. So for example, if you have a car variable, you might want to assign a value called say Honda, right? Students variable, you can assign two students like Alex and Bob. Orange count variable, you can assign a number like 53. That's what the values are, right? Then data types. What type of value? Is it a string or is it a boolean or is it a number or what kind of values these are? Right? These are basic programming concepts. Nothing to do with strongly with JavaScript. Across all the programming languages, most of the concepts are very valuable. So understand this concept first. Then you talk about operators. Okay, you want to perform certain operations in your programming, like you have to do addition, subtractions, all these operations. So you need to know about the operators. There are various operators available in different programming languages, but these operators are kind of very basic across all programming languages. Conditions. What kind of conditions? Greater than, less than, and, or, all are different kind of logical conditions. Flow control, which is like if loop, do while loop, and development in the sense is like where do you write the code, how you find the problem. Thing is function as a very generic programming concepts. Environment in the sense is like where do you write the code, what kind of editor do you use, how do you build your code, what does build mean, how you make sure that your code is reaching to your customer, how the deployment things works. Everything is related to environment, right? Set up, build, test, run, deploy, everything is environment. And the last thing is about debugging, right? How you find the problem in your code and then finally fix it. So these things, variable, values, data types, operator, conditions, flow, loops, function, environment, debugging, all these aspects are programming concepts. Those are not JavaScript concepts. So you learn JavaScript today, you learn some other language tomorrow. These concepts stay same. So first focus on these concepts, then thinking about your learning JavaScript. Okay, so change that particular thing. Now the next thing we're going to talk about concepts is more than syntax. It means that focus on context more than you focus on syntaxes. If you get a problem, for example, a problem could be I have a condition. The condition is such that if I am picking up a sheet, a piece of paper, and in the piece of paper, if I am opening, if it is written the color red, I get a red ball. If the color is written green, I am going to get a green ball. That is the problem statement. Now with this problem statement, if I have to do the programming, I have to kind of get down and start doing programming. If you first think about the syntaxes, like you wrote this programming once by looking into tutorial or books and try to memorize the syntax, it's not going to work. If the problem statement changed a bit tomorrow, you won't be able to write the program again, right? You'll fail to write the program. So first focus on the concept. So I told if in the paper it's written red, then you get a red ball. If it is written green, you get a green ball. So I'm talking about a kind of flow control. If it happens, else it happens. So I'm talking about a flow control. There could be two possibilities. Because if the problem statement is tweaked a little bit, you won't be able to write the right. Like go Google about this, or I follow it. Now we're going to talk about mind map. So in the mind map, let's take an example. Let's say I'm going to learn about this keyword. All right. So this keyword is a very important subject in JavaScript. How do I learn? Do I go Google about this, or I follow a tutorial starting with certain concepts and then reach to this keyword and then try to understand? Whatever works for you, it's great. But if you really don't want to revisit it multiple times, you have to understand for this keyword, what are the surrounding concepts that you need to master? How to mind map that? Okay, so that mind map is what I was talking about in the beginning. So for example, to master this keyword, you have to know about lexical environment in JavaScript. There's something called lexical environment. Don't look at the term, guys. The terms are like very gigantic, but there's a very, very innocent meaning of lexical environment. Going to cover that in the next video. So lexical environment, you have to know next, talk about variables, then functions. You have to know call stack. You need to know execution context. What exactly execution context? Another heavy term, but a very simple topic. Very, very simple thing to understand. You have to talk about binding. You have to understand hoisting. You have to understand scope chain. And then once you put all the dots together, you arrive to this. Now you may think, to understand one concept, do I need to understand all this concept? Yes. Even if you're not explicitly going through it, any questions that comes around this or any work that where this keyword will be used, all these concepts are coming by default. So why not to know that these concepts are going to influence this particular topic, right? So that's how the mental map should be made. So any question that you now look into from the quiz puzzle, we just talk about, hey, what is the output of this one with this keyword? You should start thinking from the perspective of hoisting, binding, how it gets executed. Okay, variables, functions, all those perspectives, and then give the answer. That's why this mind map is important. Another example of the mind map is, let's talk about JavaScript promises. Now, if we talk about JavaScript promises, how do we come to promises? Like, what are the surrounding topics that I need to get comfortable with so that I get comfortable with promises completely? Okay, you have to know about functions for sure, call stack, execution context again. There's something called task queue, there's something called job queue, and then you connect the dots. I have created a full-fledged series to make you understand promises, taking the same path. And I've got a lot of great comments from everyone gone through the synchronous series that they understood promises and they're able to solve problems. So this gives me a kind of proof that the mental model works, right? So I'm going to teach the concept like execution context, this keyword, everything through the same mental model in the upcoming videos. But go check out the synchronous series if you're interested. So this is about the mental model. Now let's go to the next topic, which is called this weird thing, the JavaScript weird thing, which we spoke about it, right? So what is weird thing in JavaScript? Something like this. The number of an empty array is 0. Null is greater than or equals to 0. This is like really weird at a glance. 0.1 plus 0.2 is it equals to 0.3? You will say yes, but it's false. If you sort it, it doesn't get sorted. The number correctly look like. These are all weird things from the outside. When you look into the syntax, don't look into the concepts behind it. That's what I told. The moment you hear that I'm weird, it is weird because to to someone who doesn't understand the concept at all, but talking about the syntaxes too much. Once you understand the concept behind each of this thing, you won't feel that weirdness. That's what I told, that if something's weird, don't care, don't bother about it, because you will understand the concept and then you understand the things much better way. Okay, so that's about the weird part. Up next, so what next about this? Next, we are going to cover some core concepts in the upcoming video. The next video that I'll be creating on JavaScript is to talk about execution context. That's why I am going to create a mind map of parser, interpreter, lexical environment, function, call stack, and then execution context. And that is what I'm going to present in front of you. That's how you're going to learn execution context. Don't miss it. And if you like this video, by the way, please do a like and share. It will be really great for me. Others will come to know about it as well. And please subscribe to the channel if you have not done yet. Thank you very much. Thanks a lot. Hi. Let me give you a JavaScript tip. Don't try to learn JavaScript in 5 minutes or 1 hour. It's not possible practically. Don't even try that. JavaScript as a language needs time for you to understand and get a grip on it. Because once you learn things fundamentally, you will be doing much better in terms of debugging and writing code and building world-class software products. Hey, this is Tapas. I keep sharing knowledge about web development, JavaScript, React, content creation, open source, GitHub on this YouTube channel. I hope you like today's video as well as you like the previous one. So in the last video, I have shared how to learn JavaScript, a few strategies that you have to keep in mind to learn the language effectively. In today's video, we are going to talk about one of the fundamental core concepts called lexical environment, which you must understand to understand how many of the following critical concepts. Before we get started, I would like to request you to subscribe to this channel, because once you do so, it gives me motivation to create more and more quality videos. And please, like and share the video so that other people also come to know about it. Without any further delay, let's get started. That's right. We are going to talk about some of the core concepts. And the core concept today we are going to learn and understand is called lexical environment. Wow, lexical environment is a heavy term, but the concept behind it is pretty simple. If you understand the concept, you won't bother about how heavy the jargon is. But before we get into lexical environment and understanding of it, if you remember our last video, we spoke about learning JavaScript with a new learning model, which is nothing but creating the mental map. So in today's video, to learn lexical environment, our mental map is about learning tokenizing, learning about parsing, learning why JavaScript is an interpreted language, and then we'll be getting into understanding what is lexical environment. All right. So let's get into understanding what is tokenizing. What exactly token means? So if you have a code snippet, for example, this particular code snippet, the token means the identifiers, the operators, each of this thing of this particular language. Now, once JavaScript engine starts seeing this particular code snippet, it doesn't run it as is, right? It has to understand whether this particular code is matching to the grammar of the language, whether this particular code is runnable, and I can execute as JavaScript in this particular code or not. For that, I have to say, if I'm creating a function, does this function has a keyword called function? Does this function has a name? Does it have a parenthesis? All this thing has to be understood by JavaScript engine, and for that, it has to break apart your code and try to build something which is called tokens. So it is breaking these things, get the things out, so that it understands what is there in your code snippet. So this particular operation is called tokenizing. Once the tokens are done, once you have the token, the next strategy is called parsing. So parsing is basically a mechanism which takes all the tokens that you got after tokenizing and build a tree structure, which is called abstract syntax tree, or AST. If you have ever studied any book of DSA in your engineering and programming, you must have heard about AST, abstract syntax tree, which help you to identify how your code should be organized for it to run perfectly, and how your code is not organized so that it don't run perfectly. So if you have broken things in the token in the left side, and then you're creating an AST at the right side, it's a tree kind of structure where you clearly can see what is a variable expression, what is a variable name, what kind of value it has, all this kind of structure that it creates. Now after this, the JavaScript engine start looking into your code line by line. So it will first look into the code called function, say name, parenthesis, a bracket. It will look into the tree, and is the tree form in a way the JavaScript engine expects, then the code will run and go to the next line, execute it. If it runs, go to the next line, execute it. If it runs, go to the next line, execute it. If it doesn't, stop there, throw an error, right? So it means it will take AST as an input and then create something that machine understands, right? That's where this particular diagram or this particular flow is something very useful. You have a source code, var age equals to 7. Tokenizing, take the keyword, take the identifier, take the operator, take the number, parse it, create an AST, okay? And then after you create an AST, the next particular thing that you can do is about create a machine code, that machine understand, that kind of code is that you're going to create, right? So it's a loop. I've kept it in loop so you can understand. Let's take it one more time. You have source code, then you are getting into tokens. After tokens, you are getting into parsing, you are creating an AST, great. You see the identifier, assignment operation, numerical, all these things are happening. Then you're creating a machine level code, which is really, really awesome thing to do. So now the next thing is like, once you have the machine level code, then basically JavaScript engine is executing this program. Okay. So this concept, as we understood, now we'll be getting into your lexical environment concept. What exactly lexical environment means? Why this is a so heavy term? Before we get into lexical environment, let us understand what does the word lexical means. The lexical means something lexically kept means it is positioned at a particular point of time. The code snippet I see, if I ask you, how the variable, where the variable name is lexically positioned. So you will say the variable name is lexically positioned at the first line inside the function called sayname. Where exactly the console.log lexically positioned? You will say the console.log is lexically positioned in the function sayname after the line var name equals to surname. Where exactly sayname function lexically positioned? The function sayname is lexically positioned inside a JavaScript file. Okay, because the function is not inside another function. In JavaScript, you can write a function inside another function. If that had been the case, I would have told function sayname is lexically positioned inside function XYZ. But that's not the case here. So lexically, you understood what exactly means. So what is lexical environment means? The lexical environment means two things. It's a combination of two things. One is the memory of what we are actually interested in to find the lexical environment. For example, if we want to find the lexical environment of function sayname, so it's a memory that function sayname occupy plus a reference or a pointer to the outer world of function sayname. Is it confusing? Okay, let's break it. So if the function sayname is having variable name, then the console.log. Think about how we tokenize, think about how we parse, think about how we have created the AST, and then think about how JavaScript as interpreted language go line by line and start executing things. So JavaScript hit the first thing called function. Okay, great. So function it means great. It got an AST, it ran perfect. It hit variable name. All right. Then it hit console.log. Then it hit and in close it bracket. Right. So it means the function sayname has variable name and a console.log statement. So this is what functions memory comprises of. This is also called environment record. In another very critical term is called environment record. So for function sayname, lexical environment is the environment record or the memory for this particular function, plus the reference to the outside world of this function. What is the outside world of this function? As the function is not defined inside another function, it is just a one function in a JavaScript file. We can assume like when this function run, the function run globally. So it means that there is nothing else around it. It's like globally running. It is not running inside another function. So the outside world will be the global area of this function. So if we break it down, the environment record or the memory for this function is this particular variable name declaration, this particular console.log, that is for this particular function, and outside area is something like a global area. So and reference to the global area. So lexical environment means, again to repeat, is the memory or the environment record of something for which we are actually trying to find out the lexical environment. In this case, the function sayname. That plus a reference or a pointer to his outside world. Why that pointer is required? Because through that pointer, it can access the thing from the outside world if it is permitted. So for example, outside of this function, if I had created another variable, for example, if that variable access is permitted within this particular function, that function would have had the access to that particular variable. That is where this reference is required. If there was another function outside of this function, as this sayname function is having a reference to the outside world, the function sayname would have had the access to that outside function also. This lexical environment understanding is required because this is the base of understanding something called execution context, how function executes, and then the scope, and then the scope change. The scope change, so that being in function, whether I am able to access something from outside, why I'm not able to access something from outside, and finally the concept of closure. So if you understand the concept of lexical environment, and it's a combination of environment record, which is nothing but the memory occupied, plus a reference to its outside world, hold this concept in your brain for now, because very soon what we're going to do, we are going to learn about subsequent concept in the upcoming videos. In this video, we learned about tokenizing, we learned about parsing, we learned about what is interpreter, we learned what is lexical environment. Up next, we're going to learn about variables and functions. Then we're going to learn about what is call stack. Then we're getting to know about execution context. So in this mental map, the next will be scope chain, and closure. Then we'll get into understanding this keyword, right? So each of these things, whenever you backtrack, there is a reason why we're talking about it, because that fundamental will make things easy for the next one. I hope you enjoyed this concept. I hope that you enjoyed this learning. And if you do so, please share this video or comment on it so that I know you enjoyed. Share this video in your circle so that others will come to know about it. And don't forget to subscribe to this channel, because I try to share a lot of things from my experience, the way I understood, and make things simple for you. Take care of yourself. I'll come back soon with the next video. Thank you. Your JavaScript application needs data. and information. Without data and information, your application will look really, really blank. And we don't want to build an application which is blank. Now, when you need to deal with data and information, you got to store them somewhere. Where are you going to store them? Hey, this is Tapas. Welcome back to the next video of this JavaScript series. Today, we are going to learn about variables, a very basic concept, very fundamental concepts. And as a beginner to JavaScript, you must have to know, what variable is and what is the difference between variable and values. These are simple things, but sometimes it might get confused. So, I want to kind of teach you this particular topic quickly, but with some amount of examples so that it connects the dot very, very well. All right, so let's look into the variables and start learning variables. If you have not subscribed to this channel, please go ahead and subscribe as I keep sharing a lot of good content over here. I hope you like them and you enjoy them. All right, so let's get started. We can start learning about JavaScript variables by writing code like let name equals to some value, but we are not going to do that way. You know why? Do you remember this slide from our previous video? Yeah, that's right. We are learning JavaScript using a new learning model, the mental model, right? So in the last video, we learned about tokenizing, parsing, interpreter, lexical environment, these topics. Now we are learning about variables and functions. Today, specifically focusing on variables. So we'll be learning how things works under the hood. Then we get into the syntaxes. That's our whole philosophy for this playlist, right? So that's what we'll be following. So let's get started. Let's get started with the variables and let's start learning things visually. Okay. Now, when we talk about a variable in JavaScript, it is nothing but a storage to store some information or the data that you use in your application. As simple as that. So if this is storage, there could be multiple such values, there could be multiple such information that you deal with in your programming. So that means there could be multiple such storages possible. Now, if there are multiple storages, you have to identify the storage some way. That's why the name comes into picture. Each of the storage will have a specific name. With that name, we can identify the storage so that we can retrieve the value that is stored in the storage, or we can put a new value into the storage. Think about us, the human being. Think about the case if we don't have name given, it will be very difficult to kind of identify each other, right? Similarly to that, in JavaScript also, we need to have storage. That is where we store the value, and the storage name is the variable name. So we have a storage, and the storage has a name, let's say fruit, and it has a value, let's say mango. So here the variable is fruit and the value is mango. Okay, so this is how we learn things visually. Now let's go and take a look of how do you create a variable in the programming. Now we'll be diving into a syntax. Again, we'll be connecting to the dots to know how things works under the hood. So how do you create a variable? What is the syntax? The syntax is you use a keyword called let or const. Then you give the storage name, then you have an assignment operator, and then you provide the value that you want to store into this particular storage, whose storage name you are using here. Now there's another keyword that you can use called var. We will be never ever talking about it. That's something I recommend you to use, but you have to know let const var a little bit deeply. When you talk about the scope chapter, when you talk about the JavaScript scope, that is the time we'll be talking about let const and var much more deeply. But for now, just think about that there is a keyword called let or const. There is a storage name equals to value. So one example could be this: let fruit is the storage name, which is nothing but the variable, and this variable is assigned a value called mango, which is a string because you see a double quote around this one, right? So this is how the variable can be declared. It's very simple. Now the next thing we're going to talk about the value assignments. We assign the value to a variable. Next, if we assign another value to the same variable, what exactly happened? Let's try to understand that visually. So let's take this line of code, let fruit equals to mango. Now you know what will happen. So there is a storage. The storage is having a name called fruit and it's having a value called mango. Now in the next line, look at carefully. I'm assigning a new value to the fruit variable, saying fruit equals to kiwi. So in this case, what will happen? If I'm assigning a new value to an existing variable, already declared variable, it is just going to replace the old value with the new one. Now fruit storage is having a new value called kiwi. Straight and simple. Okay, let's take one more example of value assignments. Let fruit equals to mango, and then we have a storage, of course, with the name fruit with the value mango, and then another expression says let vegetable equals to carrots. So we'll have another storage. Vegetable is the storage name and carrots is the value, both are string, mango and carrots. Now what we'll do, we will we'll use the assignment operator to say fruit, assignment operator vegetable. What happens in this case? If you write a code like this, in this case, what will happen? The right side one, the vegetables value, get assigned to the left side storage without doing anything with the right side storage value. That means the right side storage value, vegetables value, is going to be intact, which is like carrots. But now the fruits value is going to go off and the new value will be the carrots. So now both fruit and vegetable is having the same value called carrots. So hope this value assignment is also very clear, and how do we declare, how do we create, why do we create, all these things are very, very clear. Think about a situation that if you're writing a programming and you don't have a variable to use, how difficult it will be. A same thing, you cannot define things for once and try to use them at a point of time. It will be really, really hard. So variables are very important. Okay, now when you create variables, there are certain rules, specifically the 4 rules that you have to keep in mind. The first rule is the name must have digits or letters. Okay, that's the first rule. Second rule is that you can have special characters, but it has to be only dollar or underscore. No other special characters. Okay, so name must have digits or letters, and the name can have dollar or underscore. The first character must not be a digit. The first character must not be a digit. That's the third rule. And the last rule is like no reserved keywords. It means JavaScript has got a few keywords which are like reserved for the language. For example, the let const, we told those keywords reserved. Those are reserved. JavaScript's own programming language is keywords. Like that, there are plenty of keywords available. You cannot use those reserved keywords as a variable name. Okay, that's the fourth.
कॉलेज की चीज भाई नो कॉलेज કેવી જાની તાર મને નાઈસ টুডে এলটিআই ইন্টারভিউ তোরও আছে? বেস্ট অফ লাক ভাই। কটা স্লট দিয়েছে ভাই? চারটে। ওকে, গুড গুড, ভালো করে দিস। আর কি বলি?
one. Now what we're going to do, we are going to take some examples and try to identify which one is a valid name versus which one is an invalid name. Okay, first, let dollar equals to string dollar. Is it a valid variable name dollar? It is, because the name can have a dollar. It can also be just only dollar. Okay, next one, let tomorrow, where the number is 2, it starts with number 2. It is invalid because it is breaking this one. The first character must not be a digit. In this case, it is a digit. How about this one? Let underscore equals to underscore and let react hyphen play. This is definitely correct because it can have underscore. This is not correct because special characters allowed but only dollar and underscore. In this case, you have a hyphen or dash, so it is not a invalid variable. It is not a valid variable name, it's an invalid variable. Now let's take this example. Is it valid or invalid? In both the cases, this is valid because satisfying all these criteria. But one thing to here note, both of them says my name, but their cases are different. In this case, it starts with a capital M, a big M. In this case, it's a small m. These two are completely two different variable names. So it means these two are completely two different storages, having two different values, and the storage names are completely different because these cases are matter. So they are actually valid, but they are two different ones. So I hope this variable name rules are clear. The next thing that we're going to talk about the standards. Now we know the rules. Now when you start creating variables, what kind of standards you should follow apart from the rules? So apart from the rules, some of the best standards will be use camel case. Okay, it should be human readable. So it means that anybody looking into your code, looking into the variable name, they should understand what is the variable name is for. If you are having a counter, right, which maintains a count of something, you will probably select a name called count or counter. You won't say my name equals to 1, So, if you can give any name as a variable name, but it should be human readable. It should be something that people can correlate, people can understand. Okay, the name should match the cause. That's what basically, what your program is intended to do. And for that, if you're creating a variable, the variable should match the cause. That's the thing. And the other thing is that never ever name your variable like, I, J, K, A, B, C, D, things like that. Because this is very confusing when somebody reviewing your code. They won't be able to gauge like what is A, B, or C meant for unless they have to read through the entire logic. But if the variable name is human readable, if it is matching the cause, just by looking at the variable, they might guess like, okay, what you're going to do with this variable and what kind of impact the variable is having in your logic. One funny quote that I have heard from one of my mentors when I was learning JavaScript, these variables and things like that. The mentor told me that if you have a kid in future, and if you have to give a name of the kid, will you really give the name as say A, B, C, D, I, J, K, L? You'll probably give a name which is like more human readable, which is like more suits to some kind of character that you want your kid to develop or somewhere it connects to something, right? So think similarly for the variable names as well. Treat them similarly like your kids or child's name. So I thought of kind of giving it to you because I learned that from one of my mentors, so that if you're creating a variable, then make sure that you make it meaningful. So with that, this topic ends here. We learned about variable a lot. Up next, we're going to learn about JavaScript functions. We're going to go deep down, understanding what is JavaScript functions, why it is called the first class citizen in JavaScript programming language, how to use it, how to exploit it. And once we're done with that, then we'll be getting into concepts like call stack, hoisting, scope chain, closure, all these things, one by one. So I hope that you found today's one useful and you will make use of it. Please go ahead and practice a lot, whatever you learn, and try to learn with this mental model that we are actually getting our grip on. Okay. So I'll leave you with that. See you soon with the JavaScript functions video. Thank you very much. In most of the web development interviews, you have to face questions about values and references. You have to face questions about JavaScript objects. Hey, this is Tapas. Welcome to TapasScript, where you learn things fundamentally and conceptually. Today, I'm here again with another fundamental and conceptual video to share with you a lot of knowledge around JavaScript objects, references, and values. We'll be discussing things in and out to understand how references works, how object deal with it, what is object copy versus clone, and what kind of mistakes usually developers make in their code. We'll be going through a lot of examples, but most importantly, the entire video is created with some graphics so that you understand things, you get things very easily. So I hope you find this video really, really helpful. And if so, please like and share this video, and please subscribe to this channel so that you get notified every time I create such content, which will be very, very useful for your programming career. So without any further delay, let's get started. I believe in understanding fundamental programming concepts before syntaxes. That's the reason we'll get started with understanding from data types, very fundamental, core fundamental things in JavaScript. So what are the basic JavaScript data types? The JavaScript data types are in 8 numbers. They are string, number, big int, boolean, undefined, null, symbol, and object. And among these, they're classified into 2 different sections. The first 7 are called primitive types, and the last one is a non-primitive type. Now, the question might come, what is the primitive type? What is non-primitive type? What is the difference between primitive and non-primitive? So primitive means they're the basic types. It means a string, a number are the very basic types, and non-primitive means a complex type that is built using the basic types. So if you know about object in JavaScript is a key value pair, where key can be any string and value can be any of these primitive types. Value can be a string, value can be a number, value can be a boolean, just like that. So to keep it simple, primitive are the basic fundamental data type in JavaScript. Non-primitive, which is object as an example, is a complex data type which is built using this primitive data types. That's it, primitive versus non-primitive. Now, as we have the idea about primitive versus non-primitive, the next idea we are going to take about value versus reference. So this is another thing. When we get started with programming, we very loosely use things like, okay, this is why value, this is why reference, but this is where I feel that most of the mistakes as a developer we do. We don't understand these concepts very fundamentally, so why we cannot catch things in code if sometimes it is going wrong. So let us understand the difference between value and reference. We now know primitive versus non-primitive. So in primitive, the value is handled by value type. In non-primitive, it is handled by reference type. What is value type and what is reference type? In case of value type, the value is handled by the actual data. Imagine there is a box.
Good morning, brother. I'm nice. I'm good learning JavaScript. That's all.
and you want to assign some value to it, say value 10. So you will be keeping the value 10 directly inside this box. Imagine it in this way. So it means for any primitive that we have learned, be it string, number, boolean, or whatever it is, the value that we assign to them, the data that we assign to them, it is the actual data that we are assigning to them. The actual data is what is getting assigned to them or will be stored in them. But in case of reference type, the thing is different. In case of reference type, it will hold a particular memory address on which the actual value is stored. Sounds a little confusing. Okay, let me break it up. So for example, if there is a non-primitive thing that you're dealing with, for example, it's an object, and the value of the object will be stored somewhere in the memory, and that memory will have a unique address. So in this case, the address is x0s4. Now for reference type, the variable won't hold the actual value. Rather, it will hold that memory address in which the value is stored. So in this case, the variable will store the value x0s4, and in that memory address x0s4, the actual value count 10 is stored. Think it this way. So that's how primitive and non-primitive handles their values in a value type way and the reference type way. I hope this is clear now. Now we will write some code about primitive things. We'll try to understand some use cases. Also, we'll see things visually how it gets represented before we get into understanding of reference type. So let's get started. I'm using Chrome's debugger tool, the console. You can use any editor, but I feel this will be very easier for me to write code and instantly get the output. So let's get started with creating a variable called count and assigning it a value with 10. So what does it happen? So it means that we are trying to assign a primitive type value, 10 is a number, a primitive type value, and trying to store that in a variable called count. As simple as that. So when we are trying to assign a value, equals is the operator through which we can do the assignment. Value get stored or get assigned to that particular variable. So it means wherever I use count, I will get this particular variable value back directly. Similarly, if I do late item equals to 20, is the same case happen that now there will be something gets created, labeled as item, and the actual value 20 is getting assigned to that. So if you try to see this pictorially, it will look like this. The count 10. So there is a store gets created, it's labeled as count, and the actual value 10 goes into it. And the value of the count is 10. If it is item equals to 20, so there is a store and it's labeled with item, the actual value 20 is in it, and the item value is 20. Quite simple, isn't it? Now let's make it a little more tricky. How about we do count equals to item? Now, what will be the count's value and what will be the item's value? We can see already, right? The count value is 20. Item value is also 20. Why is it so? So here the thing happening is something called pass by value. I think we heard it this term a lot, pass by value. In pass by value, a new copy of the value will be passed. So it means when you do count equals to item, what was item's value? Direct value was 20. So a new copy of this value 20 will be passed to this count. What do you mean by new copy of this file? Because later point of time, if I change item, that is not going to change the value of the count. Okay. So right now I have assigned item to count, item's value was 20, so everything become 20. But later point of time, if I change item equals to 30, that is going to change only item's value. It is never going to change count's value. Count will remain 20. Okay. So every time you assign something, it is directly getting stored to this, and it doesn't have any reference to anywhere because we are handling a primitive value or primitive data type. Now see this pictorially. So in this case, if we do count equals to item, what happened? The 10 goes off, a new value 20 comes here. The count value
What do you mean, brother? I slept. I just woke up early. That's all.
becomes 20, but item doesn't change because count and item are two different things value wise. Their values are two different copies, not the same copy at all. Now if we do item equals to 30, we'll be only changing item's value to 30 and item value will be 30. Count will be unchanged unless we assign something again to count like 50, then count will be 50 and here count value will be 50. So this is how pass by value, this is how value assignment works in JavaScript. The next thing that we're going to do, we're going to talk about non-primitive or the object type. I'm going to see how the object assignments, object copy, all this is going to work. Let me introduce JavaScript object to you. So what is JavaScript object and what is the way that we can create an object? One straightforward way of creating an object would be using the object literal. Let's create an object called user, and it can be created with a pair of curly braces. If you don't specify anything within it, you are creating an empty object. But if you need some property within the object, you'll be creating them with key value pair. Key can be a string and the value can be any of those primitive data type, including string, number, boolean, whatever, right? That's when I told the primitive data types are the basic data types, and when you create a non-primitive thing like a complex thing, you'll be using those primitive data types. So the user object's property value can be any of this non.
Bro, I every day wake up early. What do you mean? I usually woke up at like 5:30.
Primitive data type that we have seen. So in this case, we'll create a string and we'll give the name as Sam. We have created user equals to an object. Now I'll query user and it gives me name equals to Sam. And this is the source of all the confusion. When I did count equals to 10 and printed count, I got 10. When I did user equals to an object, printed user, I got the object back. So it gives me a perception that the user variable is actually storing that object value, which is really not true. In this case, the value is handled by reference type. What does it mean? It means that the object name colon Sam gets stored somewhere in the memory, some location in the memory, and that location is having a unique address. Just like our house is having address, we have email address, something unique to identify a location. So the location in the memory will be identified by that address. The user variable will have the knowledge of that particular memory address. So whenever I'm querying user, it will know on which memory address this particular object value is stored. So it will go to that memory address, query, and get you back the value of this object. That does it mean? It means that 10 and printed count I equals to the basic data types, and when you create a non-primitive thing like a complex thing, you'll be using those primitive data types. So the user object's property value can be any of this non-primitive data type that we have seen. So in this case, we'll create a string and we'll give the name as Sam. We have created user equals to an object. Now I'll query user and it gives me name equals to Sam. And this is the source of all the confusion. When I did count equals to 10 and printed count, I got 10. When I did user equals to an object, printed user, I got the object back. So it gives me a perception that the user variable is actually storing that object value, which is really not true. In this case, the value is handled by reference type. What does it mean? It means that the object name colon Sam gets stored somewhere in the memory, some location in the memory, and that location is having a unique address. Just like our house is having address, we have email address, something unique to identify a location. So the location in the memory will be identified by that address. The user variable will have the knowledge of that particular memory address. So whenever I'm querying user, it will know on which memory address this particular object value is stored. So it will go to that memory address, query, and get you back the value of this object. Now let's see this pictorially so that it makes more sense to you. Let's imagine this is our JavaScript memory space where there are a few memory locations already defined. If you can see those memories, and there is their memory address specified in some number. Now let's imagine there is one more memory location whose address is q5zz, and in that location the name Sam, this particular value is being stored. Now when we assign let user equals to name Sam that object, it means that the user variable will now have this particular address, the reference address in it, that is q5zz. It is never going to have the name Sam object value directly. So whenever we are querying, it knows that q5zz is its memory address that it needs to query for a lookup to. It does a lookup and it will find name Sam, this particular value, and fetch it. Let's take one more example. Now we'll create one more object called employee, and we'll add a property called name and give a different value called Alex. So in this case also, we are creating another object called employee. That means we are creating another memory location. We are having address for that memory location, and the employee variable will have the reference to that particular memory location through that address. So pictorially seeing, we'll create another memory location. It will have an address. In that memory location, we have name Alex, and then the variable that we have created employee, which will have that address referenced. So whenever we query through this reference, it can fetch the name Alex. You got it? It's very simple. Now one more thing that we're going to see. When we do let count equals to 10, let item equals to 20, and do count equals to item, we did this, right? What we did, the value, the freshly copied value was assigned to count, right? And when we changed the value of item later to 30, it never changed the value of count, right? This is how the primitive pass by value works, but pass by reference is a bit different. So we have this user object we know, and we have this employee object we know. right? Correct? Now, what happened? If I do user equals to employee, what exactly happened? If I do user equals to employee, so it means after that, if I do user, I will see name Alex, which was actually employee. Now, at a face value, you might feel that the things happening here is exactly same as it happened with primitive pass by value occurrences, but things are a bit different. First, we'll understand pictorially, and then come back here and show that what difference it is and how big is different, and this is may cause a number of bugs in your code. As we have done user equals to employee. User equals to employee means we are not assigning the value that's stored in employee's memory to user's memory. What is user holding? User holding Q5ZZ. What is employee holding? Employee holding X0S4. So if I do users equals to employee, it means now user and employee both will be holding X0S4, the reference value, because we are doing user equals to employee. The value of the right side will come to the value of the left side. When you do user equals to employee, employee's value is X0S4, that also get assigned to user. That means both employee and user now will have the value X0S4. Now if that happens, both employee and user has the value X0S4, that means from now onwards, user is going to point to X0S4, isn't it? So that's when you do user equals to employee, both are now pointing to the same memory location. And on that memory location, we have the value name Alex. So now user and employee pointing to the same memory location, which is having the value name Alex. Now the fun. What if I change employee? So I'll change employee dot name and I'll give this name as Tapas. So I have just changed employee's name. So if I print employee right now, I'll find name Tapas. But I have not touched user. If I print user, why it is coming name Tapas? Now it can be very well understood through this picture. What if you change name Tapas instead of Alex at the top? Both user and employee will be named Tapas, isn't it? Because they are pointing to the same references. This is where most of our developers get confused when they try to understand references. Because in references, they think about value. In references, you have to always think about the memory addresses. This picture, you have to imprint in your brain whenever objects coming into picture. Whenever objects variable equals to some object value, you should imagine right side, there is no object value. There is a memory address. Behind that memory address, there is a value. So whenever you're doing this assignment on, only this memory address is getting assigned. The value is getting intact, untouched in that particular memory address, right? So now name equals to Alex become name equals to Tapas, ABCD, whatever it is going to impact both employee and user. This is what is called passing by reference. One question though, what will happen to name Sam? What will happen to Q5ZZ? What will happen to that particular memory location? Now here, there is a concept of garbage collection. Not only in JavaScript, in many popular languages, the garbage collection takes place wherever we deal with object and something we store in the memory. So if there is no strong references to that particular memory location, which we see, there is no references, it means that nothing is referring to Q5ZZ. At least for other three, at the bottom, there is a dotted line reference. So that means something is referencing. We are not able to see it in this picture because we are not bothered about them. But Q5ZZ, nobody is referencing. So JavaScript garbage collection cycle is going to garbage collect them, free up that memory. Later point of time, somebody else will be able to occupy that memory. Some other object can use that memory and do something with it. So I hope the references, garbage collection, all these topics, all these fundamentals are very clear to you right now. In JavaScript, whenever we're dealing with objects, copy is not the same as clone. Okay, so I have seen developers use the term copy and clone interchangeably. It's not exactly same. Copy means what we saw right now. We did user equals to employee. Both the references become same. Both are pointing to the same memory address. If we change the value in that memory address, going to impact both. That's purely copy. But when you do clone, when you want to do duplicate of an object, you mean that you want to create a new memory location. On that new memory location, there will be a value. Okay, so how do we create clone and how do you do cloning? Let us see that. Let's assume you have two cars. These two cars looks identical. We are talking about the scenario of copy. All right. Now this car's value, the property of the car, what are the color, how many tires are there, how many headlights are there, how many doors are there, all these properties are stored as value somewhere in the memory locations. Let's say color and light, both are stored. Now in case of copy, both the objects will point to the same memory location, the one that we have just now seen. Okay, this is how it's copy. But when you talk about clone, it's not the case. In this case, the individual memory locations will be created, though the value stored in that memory location may be exactly same, because that's why it is looking exactly to same car, but they are pointing to their own references. So it means in the left side car, if I change the color blue to green, only one car will change to blue to green, other one will still remain in blue. But in case of copy, where it was pointing to the same, if I change the color blue to green, both the cars are going to be green color car. So this is the fundamental, guys, between copy and clone. Please keep it in mind. Now we'll see things in code of how to clone an object, because we have already seen an example of copy using user and employee. So we are starting again with the user object we have, the employee object we had. User and employee both were pointing to the same memory location, holding the same value. So if we do whether user is equals to employee in this case, we will find it true because they're pointing to the same reference. And please notice that we are comparing them with the strict equality operator, which is 3 equals. We are not doing them with 2 equals. We never use 2 equals, always use triple equals. So comparing them with user, triple equals, employee, we're finding they are exactly same. So it means it's a copy, C-O-P-Y copy, so that you never forget. Now we're going to talk about clone. So let's take this employee object again, and we'll be creating a clone of this particular employee object. How do we create it? To create a clone, there are multiple methods. We can use a method called object.assign, which I won't show here because the future video I want to teach you what are the different ways of creating object, and there I'll teach you object.assign. But right now I'm going to teach you how to clone an object using spread operator. How do you do it? So you have an employee object already. You take the employee object, and just before the employee, you put 3 dot. This is how you spread and create a new instance of the employee object. And then you want to hold this instance in something. And there I'll teach you object.assign. But right now I'm going to teach you how to clone an object using spread operator. How do you do it? So you have an employee object already. You take the employee object, and just before the employee, you put 3 dot. This is how you spread and create a new instance of the employee object. And then you want to hold this instance in something which we call, say, clone employee equals to employee. Okay. Now, if I print clone employee, it will have the exact value of employee. But if I do clone employee equals employee, I will find it false, because though the value is same, now clone employee is pointing to a new memory location where the same value is stored. Employee was pointing to one memory location where the same value was stored. So now think about the card, the second case where we did the clone. Now two different objects are pointing to different memory location, and each of the memory location the same value name tapas is stored. Now if I go ahead and change employee dot name equals to Ravi and then print employee, I will say name equals to Ravi. But if I print clone employee, I will still finding tapas. It won't change because they are pointing to two different references. So I hope this is clear that how to clone. The spread operator works great as long as you don't have any nested object. What is that? Let's take an example with this user where let user equals to an object which is having a key value pair name and tapas, and there is another property called address whose value is another object. So it's a nested object, an object within an object. Now if I use spread operator that we just now learned to create a clone, something like this, let cloned user equals to spread operator user is going to create a clone for sure. So if you have cloned user, you would find that this is the exactly same user clone. Now what if I change this user's name? Okay, I change user dot name equals to Ravi. Great. Now if I print user, I will find the name has got changed to Ravi, and I didn't touch the address, as address is as it is. Now if I print cloned user, I will still find it tapas because this is clone. Remember, it's not copy. They are pointing to two different references. All great. But there is a catch. The spread operator does a shallow copy. So it means it is not going to take care if there is a nested object. For nested object, it's still going to make a copy. A shallow copy is not going to make a clone. What does it mean? Now for user, there is a street and there is a city as properties for address, right? So what I'm going to do, I am going to create the clone again so that I have a fresh clone. Now I'm going to change user dot address dot street equals to a new value. Let's say 360 first cross. So we are creating a clone, right? So it means that still the user object's value and the cloned user object's value should be different just now as we have seen for name, but we won't see it because now we are actually referencing with the nested object. So for nested objects, the clone doesn't work with spread operator. It will still be a shallow copy. So if you print user object now, you will see name tapas, address is 360. If you print cloned object now, cloned user now, you are seeing name tapas and you are seeing address is also 360. That's bad, right? So this is what the problem is with the shallow copying. But if you don't have any nested object, if you have just one level thing and your all property values are primitive values, there is no non-primitive value as a property value, you can very well use this spread operator to create clone. Now to clone something with the nested objects, it also calls deep cloning. You have to use another API that JavaScript provides. So for that, let's create the user object once more and let deep cloned user equals to, we are going to use a API called structured clone, and in that we are going to pass the object that we are going to clone. Okay, so now we have created something called deep user clone. So deep cloned user is exactly same as whatever we had created. Now let's do the same thing. Let's change user address street. So we'll do user address street equals to 360 first cross. Let's print user, the name is tapas, address is 360 first cross. Let's print deep cloned user, the name is tapas, address still remain 234 second cross. It didn't change to 360. So it's a pure clone, pure deep clone. So whenever you want to use deep clone, please use this particular API called structured clone. Whenever you want to use maybe a shallow copy, then or the first level clone, use the spread operator the way that we have showed you. There are many other libraries like Lodash and many other libraries which helps you to do deep cloning. But right now, if you look into structured clone, it's a global function and it's available on all the browsers, all the modern browsers. So if you using modern browser, you can always use structured clone and can read more about it. The link is in the description of this video. So how was it, guys? Do you feel like dancing? Did you learn something new? Is it clear for you, like what is pass by value, pass by reference, what is object references, all these things? So if you enjoyed this video so far, why don't you like this video? just press the like button. Why don't you share this video in your circle so that more people come to know about this video and more people get the benefit just like you did. And if you have not subscribed to my channel, why don't you subscribe? Because if you subscribe, it gives me a lot of motivation to create a lot of good fundamental videos. And at the same time, if you subscribe and hit the bell button, you will get notification on the amazing content that I'm going to create in the future as well. So why wait? Like, share, and subscribe. Thank you very much for watching. I'll come back again with another fundamental video very soon. Keep watching. Be a subscriber of TapaScript. Thank you. Hello people, how are you doing today? Welcome back to your channel TapaScript, where you learn things fundamentally
Welcome, but I'm very sleepy. I don't know how much I can go on for. Uh, I guess Chris can recommend you some. Chris knows a lot of, programming Discord servers. Yeah, it's him.
and conceptually. Today we are going to talk about another fundamental concepts from JavaScript objects. It's about object creational pattern. You really cannot go far in JavaScript if you don't understand objects and
No matter if you're coding in Java, Python, or even Golang, according to me, having a decent command of C is essential. The two most important aspects that C helped me understand are number one, how IO really works along with its limitation and nuances. Second, how your code interacts with kernel to get things done via system call. To understand this better, build these two projects in C. Number one, build your own shell. This will give you exposure to system calls, process management, and pipes. Number two, build a very simple word dictionary in a single file. Not an HTTP API, but regular function that does file IO to perform simple CRUD operations on the file. This will give you exposures of all things related to IO and file handling along with its limitation. By the way, these were the two assignments from my college days, and doing them helped me build better understanding of how things work under the hood. I'm not asking you to give up on Java or Python, but I'm just nudging you to understand C a little better and become a better engineer. No matter if you're coding PayPal recently open sourced the key value database named JunoDB, and I spent a few days going through it to understand